Okay, so welcome everyone to Learning Module 3. In this lesson, we will focus on dynamics, specifically on speed, velocity, and time. So these concepts may sound familiar because you encounter them every day. So like when you walk, ride on a jeepney, or even check how fast your internet loads. So today we will connect these everyday experiences to scientific definitions used in physics. So at the end, by the end of this module, you should be able to explain the relationship between speed, velocity, and displacement and time. So you will also learn how to calculate speed and velocity using given data. Of course, that is with interpretation of velocity on a time graphs and recognize that organism that includes us, you and I, move at varying speeds in daily life. So these outcomes will guide that what we discuss and practice throughout this lesson. So let's start with speed. Cool. Okay, so speed tells us how fast an object is moving, but it does not tell us the direction. So in physics, speed focuses on distance traveled over time. So you can think of speed as answering question how fast. That is speed. And for now, we will go to ah okay. So let's go now to what we call the um wait. Thank you, Miss. Instantaneous speed. So instantaneous speed refers to the speed of an object at a specific moment in time. So for example, if you look at the speedometer of a car, the value you see it is its instantaneous speed. So even though velocity includes in direction, instantaneous speed only considers the magnitude or how fast the object is moving, regardless its direction. And um, is average velocity. Okay, so when we say average speed, this is different from instantaneous speed. It is calculated by dividing the total distance traveled and by the total time spent traveling. So this is useful when motion is not constant, such as during a trip when you stop, slow down, or speed up. So in this example, a person travels 6 kilometers, right? 6 kilometers in 30 minutes during a round trip. So when we compute the average speed, we get how much? 12 kilometer per hour. That's the average, and which is also given in this word problem. However, notice that because the person ends up where they started, the displacement is 0. So which means the average velocity is also 0. So this shows that speed and velocity are not the same. Oh, okay, so let's use Usain Bolt, one of the fastest runner on Earth. So in real life, we have this person, Usain Bolt, in 2019. Um, eh, it ran 100 meters in 9.58 seconds. So this illustrates how speed can be measured in sports and helps us appreciate how fast elite athletes move compared to ordinary human motion. Okay, let's go now to velocity. So velocity includes both speed and direction naman. So if you move fast but change direction, your velocity changes. So this is why velocity is more specific than speed. Kasi nga, it answers the question, how fast, in what direction? So the average velocity is defined as displacement divided by time. Now, because displacement include direction, average velocity is considered as a vector quantity. So this means that two motions with the same speed can still have different velocities if they move in different direction. Let's go to about vector nature of velocity. So in this slide, it emphasizes that velocity has both magnitude and direction. Magnitude. Oh, it's not here. Magnitude and direction. Uh-huh. Ayan. Towards the rear of the plane. Yes. Magnitude and direction. So the SI unit for velocity is meters per second, or ms. Meter per second. So when displacement is negative, the velocity is also negative, indicating motion in the opposite direction. So this helps us describe motion more accurately, as we can see. Okay, let's go for time. Time is a fundamental concept on physics. So we define time as the interval over which change occurs. So without change, we cannot measure time. So whether it's the movement of clock hands or heart rates or the swing of a pendulum. So time is always measured um, through change. So let's go to measuring time. So the SI unit for time is the second. So symbolizes by small letter S. So devices like clock and the pendulums help us measure time accurately and allow us to determine the sequence of events and what happens first and what happens next. For the elapse time, this one represented by a triangle and then T. This is the difference between the final time and the initial time. So the delta symbol means change in. To make calculations simpler, we often assume that motion starts at time 0. especially when using a stopwatch. So for checking your understanding, this activity helps you develop a real-world understanding of speed. You are encouraged to convert familiar speeds into meters per second and estimate speeds of everyday motion such as walking, jogging, or even the movement of small organisms. So this helps connect physics concept to real life experience. I would like you to write your answer in the comment section. Okay. In this problem, the commuter train travels to Washington, D.C. and back to Baltimore. So since it returns to the starting point, the average velocity is 0. So however, because it covered a total distance of 80 miles, the average speed is not 0. So this reinforcement reinforces the difference between speed and velocity. I would like you to write your answer in the comment section. Hmm. All right. So if you have any question about the concepts discussed in this module, feel free to message me or in MS Team. And this ends our lesson for today. Thank you so much, and I'll see you again. Goodbye.